so we have moved on to the final page of the Math Review 1 homework, and let's start working through these problems. So if you read this prefix up here, right, you'll see that what we're talking about is that you're probably familiar with mathematical expressions that have numbers in them and some variables. And basically the point is that we can have mathematical expressions that have all variables and manipulate them in the exact same way. So we're going to do some of that down here. So the first thing is if we have an equation where a equals f over m, right? These are all just stand-ins for numbers. Rearrange all those variables to see what m equals. So we know what a equals. We want to know what m equals. So let me rewrite this. A equals f over m. If I want to know, if I do this out in a few steps, if I want to know what m is, I multiply m over, right? So then I would have ma equals f, and then I would divide a over here to have m be f over a. So that's what I'm going to use for what m equals in part B. So now I use the values of a, and there was a correction here. A equals 1.5 meters per second squared, and f equals 6 kilogram meters per second squared. Now, don't concern yourself with trying to make sense of these complex compound units. This one we'll talk about. Meters per second squared is a very common one and has real meaning to it. Kilogram meters per second squared, more complicated. Don't worry if this doesn't make sense to you at this point. So we have values for both of these. We're going to plug them into our derived equation and solve for the value of m. And then we better get an answer 4 kilograms, otherwise we were wrong and we'll have to go back. So let's see. If I have m equals f over a, right, I got f is 6.0 kilogram meter per second squared over my a is 1.5 meters per second squared. So I do 6 divided by 1.5. That gives me 4, yep. And then let me check my units. So I'm going to do kilograms, meters. The seconds squared will cancel. My meters will cancel. Perfect. So I have 4 kilograms. Now let me actually do out that unit cancellation for you a little bit more explicitly in case that's something you're struggling with a little bit. So kilograms, let me write it out this way. Kilograms meter per second divided by meters per second squared, right? And you guys, I think, are familiar with the copy change flip rule. So what we can do here is keep our top thing, right? Kilograms, meters, that's very sloppy. Kilogram meters over second squared. Change the sign of our middle thing from division, this big division, to a multiplication, and flip our bottom thing, meaning put second squared on top, meters on bottom. So second squared over meters, right? So now I can see very clearly the meters cancel, the second squared cancel, and all I'm left with is kilograms, which is what I want. All right, let's see the next problem. If k equals 1/2 mv squared, then v equals what? What does v equal? So we want to rearrange this to solve for v. So let's see, k equals 1/2. I always like to rewrite these, especially with the fractions stacked vertically like this. I'm going to try and isolate v squared first. So the first thing I could do is multiply by 2 on both sides, which would get rid of this 1/2, put a 2 over there, right? I could do 2k equals mv squared. I could divide by k next. Let me put arrows here so we know what we're doing. I could do 2k divided by m equals v squared, right? And then I can take the square root of both sides, and then I would get what v equals. And v would be this bit here, square root of 2k over m. So that's the equation we're going to use for v. Down here, just like the last part b, we're going to use that with some values to see if we get the right answer. And this time we better get 4 again, but a units of meters per second. So let's see if we get that, if we plug stuff in. So I'm going to do V equals 2 times 1600 kilogram meters squared per second squared divided by 200. This was a correction as well. This is kilograms. We should always write our units. Square root everything. So let me do what the inside is first. So 2 times 1600 is 3200. 3200 divided by 100 is 32. Divided by 2 is 16. So this is square root of 16. My kilograms cancel. And I have meters squared per second squared. This is a good sign because I still have a square root here, and it's going to get rid of my squares. So this is going to give me 4 meters per second, just like I want. Perfect. So that means our equation must have been right for part A. All right, let's move down here. The following equations to solve, rearrange the following equations to solve for the given variable. Okay, so number 3, if P equals V, let's change colors here. If P equals V squared over R, then R must equal, right, so let me rewrite this, P equals V squared over R. I can get R times P equals V squared, and then we want R by itself, so R would be V squared over P, so that must be what we want. R is V squared over P. And now try the following variables. V equals 10 volts, P equals 200 watts. Plug them in, see what we get. If we plug those into our equation here, it's going to be V squared, so 100 volts divided by 200 watts is going to give me 0.5 volts squared per watt. All right, let me move this stuff out of the way. Shrink it. Put it right there. Okay. V is going to be, if we solve this equation right here for V instead of R, we're going to do, we could get this step just like we did up here, R P equals V squared. But instead of getting R by itself now, we can take the square root of both sides and end up with V equals square root of R times P. And so if we plug in some numbers for that, we're going to have 12.5 watts for P, and R equals 0.5 ohms, right there for R. And that comes out, and if I multiply those and then take the square root, that comes out to 2.5. And that was another correction down here. The answer key said it was 5. It should be 2.5. All right, number 4. If V squared equals U squared plus 2AS, then A equals, so we want to solve for A. And this is just a long, complicated equation to give us something to play with, to have some fun with here. So the first thing I could do is move my U squared over, right? That's a pretty simple step. I'm trying to get towards getting my A by itself. I could divide both sides by 2s. So I would have V squared minus U squared over 2s, right? If I divide this side by 2s, it'll get rid of the 2, it'll get rid of the s, it'll leave me with the A that I want. So this must be, and I'll need to move this stuff out of the way again. This must be V squared over U squared, or minus U squared over 2s. And if we plug in all these values to that, we get A equals 16. And we want to rearrange it now for U. So similar to what we just did, instead of subtracting a U over first, I could subtract 2AS over. So V squared minus 2AS equals U squared. And then I'm going to want to take the square root of both sides to get U by itself. So U is going to equal this thing, the square root of V squared minus 2AS. Close my square root. if I plug in all these things for V over here, and A over here, and S over here, I end up with U equal to 5. All right, and we are done with all 3 sheets of Math Review 1.